The James Webb Space Telescope has just discovered galaxies that break modern theories. We are now at the beginning of a new scientific era, and nobody knows at the moment where this journey will go. Only one thing is certain. The latest findings are groundbreaking, staggering, and will change our understanding of the universe forever. The James Webb Space Telescope is a $15 billion technological marvel, exceeding the Hubble telescope in range and sharpness of images by a wide margin. This telescope has been providing us with fantastic images of the early universe, distant cosmic nebulae, menacing black holes, and planets in our own solar system since the summer of 2022. With 16 honeycomb-like mirrors and unique infrared technology, it's the most extraordinary telescope we humans have ever built. It sounds crazy, but this telescope was the hope of many thousands of astronomers on this Earth. They eagerly awaited its launch, knowing that the telescope's new capabilities would soon show them things they had dreamed of all their lives. They counted on the truth, on the confirmation of ideas that had long been only theories on paper. And then came the shock. The JWST did its job very well. After the telescope was safely placed in space, it pointed its mirrors for more than 72 hours at an area of the cosmos that appeared almost empty. However, this area appears empty only to us when we look up at the sky from Earth. James Webb catches the oldest light signals of the universe exactly here, where no stars or nearby galaxies interfere in the foreground. The telescope can pick up light signals that have been traveling to us for 13.5 billion years or more. In this image, after extremely long exposure times, these older signals appear as blurry red specks of light. Orange light is already a bit closer to us, the yellow one even closer, and the well-recognizable blue or white light spots come from the nearest light sources. Almost all light signals on this photo are not at all from single stars. Here, we see predominantly the light of very old galaxies. These galaxies shake science. It will surprise you, perhaps, to learn that many scientists suddenly were not so happy about what they had longed for so long. The outcomes did not align with their expectations. Astronomers and cosmologists immediately began scrutinizing the image, anticipating it would reveal the oldest galaxies in the universe. However, uncertainties lingered about the galaxy's true age, their structure, density, and elemental composition. The revelation struck when Indian-American researcher Rohan Naidu discovered a galaxy existing a mere 300 million years after the Big Bang, setting the stage for a series of similar findings by his team and other international researchers. As reports overflowed, it became evident that the Big Bang Theory and the established cosmological worldview faced challenges. These galaxies existed during a period when only star prototypes were presumed to exist. Despite the unexpected turn, this discovery spurred dedicated young researchers to think differently, encouraging them to seek even older galaxies and consider possibilities rejected by conventional research. This influx of new findings has given rise to novel theories and a re-examination of old models of the universe that may have been overlooked. Essentially, our cosmos is undergoing a scientific reinvention. While the James Webb Space Telescope disappointed those who hoped for continuity, it served as a confirmation for those who long believed the Big Bang Theory was not entirely compatible with modern quantum physics realizations. The pursuit of truth about the origin and nature of our universe continues unbound by reliance solely on existing theories. This evolutionary trend was predictable, evident in one of Hubble's prior significant discoveries, the galaxy GN-Z11, existing at a redshift of 11.6, roughly 420 million years after the Big Bang. This earlier find, though perplexing at the time, laid the groundwork for understanding the relationship between redshift and the age of observed galaxies. The recent discoveries with redshifts as high as 20Z face some skepticism from conservative scientists, who emphasize the need for confirmation and proof of their true galactic nature. Nevertheless, the light is undeniably there, and it is clear that it must be old, very old. In fact, if it was not emitted by galaxies, where did it come from? How is the age of galaxies determined? A common method to detect and determine very old objects in space is SMACS J0723, a gravitational lensing effect. Astronomers led by Sharon Ann of the University of Missouri-Columbia have used it to find 88 candidate galaxies beyond a redshift of 11. Yan's team thus also found the galaxy that has the incredible redshift value of 20Z. These galaxies would be the most distant ever discovered if they can be confirmed. High redshift galaxies were discovered in 2 other studies, in which JWST used only deep exposures without using gravitational lensing. These photos are part of the Cosmic Evolution Early Release Science (SEWERS) study. SEWERS worked with evaluations from JWST's near-infrared camera and IRCam, as well as the NIRCam findings. Additional data on the presumed galaxies were determined with JWST's near-infrared spectrograph (NIR-SPEC). Using other instruments, such as the mid-infrared instrument, MIRI, or the MIRI camera, astronomers at the University of Edinburgh used a similar approach to discover another galaxy candidate with a redshift of 16.7. That means this galaxy existed just 250 million years after the Big Bang. The team, led by graduate student Callum Donnan, found 5 other galaxies with redshifts greater than 12. Another team, led by Stephen Finkelstein of the University of Texas at Austin, used the SEWERS method to discover a galaxy with a redshift of 14.3, placing it 280 million years after the Big Bang. This galaxy has since become known as Macy's Galaxy. Finkelstein promptly turned the discovery into a birthday present for his daughter, Macy. These galaxies are so far not confirmed because we cannot see clearly that they are really galaxies. Our technologies are not yet sufficient for that. The computers work with the light spectrum and analyze it. The computer assumes that the light was emitted by galaxies. Then certain algorithms analyze the light spectrum and come up with fairly accurate values on size, density, mass, number of stars, and so on. However, this does not prove that this light was really emitted by galaxies. Ultra-supermassive black holes, which can also shine brightly under certain circumstances, are now also being discussed. If the computer gets the assumption that the light is black holes as a basis for its calculations, the results turn out differently. So the weaknesses of the present technology lie in the determinability of what we really see there. But even if the light was emitted by black holes, we must ask ourselves how such gigantic black holes could have existed shortly after the Big Bang. All these distant galaxies show evidence of significant emission of ultraviolet light. This again provides evidence for the ionization of hydrogen gas, which according to our previous cosmological models, should have ended the cosmic dark ages. During the dark age, there was no light in the young universe. Only when the first stars began to shine did the universe brighten. In their paper, the Edinburgh team calculated the ultraviolet luminosity of candidate galaxies between redshifts 8 and 15. The amount of ultraviolet light emitted by these galaxies at any given time is averaged using the measurement techniques presented earlier. Galaxies generally emit more ultraviolet light than young, hot stars. Donnan's team has concluded that there was actually more than enough ultraviolet radiation emitted by stars in these early galaxies to ionize the universe. This means that these newly discovered high redshift galaxies may well have existed on the cusp of becoming light in the cosmos. Unlike today's galaxies, which can host hundreds of billions of stars, these galaxies are most likely only a few thousand light years across and contain only tens of millions of stars. According to the experts from Scotland, the newly discovered galaxies reflect generations of galaxies that were formed shortly after the first ones and are still in their infancy. The abundance of high redshift galaxies discovered by the JWST, as well as the amount of ultraviolet light shifted to the longer infrared wavelengths, further suggests that galaxies were more numerous in the early history of the universe than previously thought. This would be a completely new finding, but it does not necessarily overthrow the Big Bang theory. We would only have to correct our previous assumptions about the duration of the dark ages and the formation of the first stars and galaxies. The existence of the early star giants was already proven computationally. However, researchers did not assume so far that these first large stars were already organized in galaxies. Astronomer Renuet Sin of the University of California, Santa Cruz, compared Hubble and Webb photographs of the same galaxies taken around cosmic noon. Most large galaxies appear to be significantly smaller in the infrared wavelengths measured by Webb than in the Hubble photos. According to Tsin, the Hubble studies revealed that galaxies start small and expand over time. However, the Webb results suggest that Hubble did not see everything, indicating that galaxy evolution may be more complex than previously thought. Click subscribe now and look forward to many more exciting videos from our channel Digital Discoveries.